Let's do vectors in 3 dimensions. We will use familiar XYZ coordinate system to decompose vectors in 3 dimensions. Everything is very similar to resolving vectors in 2 dimensions. Let's put vector A in XYZ coordinate system so that its tail is at the origin of the coordinate system. Then the head of vector A will be at some point P. Notice that point P has coordinates which are projections or shadows of point P on x, y, and z axes. Components of vector A, which are vectors A of x, A of y, and A of z, are projections or shadows of vector A on x, y, and z axes. Vectors A of x, A of y, and A of z add to equal vector A using the law of vector addition, like this. Using the Pythagorean theorem, we can write an expression for the magnitude of a vector A in terms of its components, like this. Again, we have unit vectors. Unit vectors are always pointing in the direction of positive axes. They have magnitude of 1 and only specified direction. The unit vector in x direction is x roof, in y direction y roof, and in z direction is z roof unit vector. We can write vector A of x as a product of magnitude of a vector A of x and unit vector x roof. Similarly, we can express vectors A of y and A of z. Now, we can rewrite vector A in terms of 3 components as in following expression. Let's do an example of resolving a vector in 3 dimensions. We have vector A in component form 3 minus x roof, 2y roof, and 3 minus z roof vectors. We know that vector A is equal to sum of its component vectors, A of x, A of y, and A of z. As we can see, A of x is 3 minus x roof, A of y is 2y roof, and A of z is 3 minus z roof vectors. First, let's draw unit vectors in coordinate system. When we have minus in front of a unit vector, we draw it in opposite direction. So these are 3 minus x roof vectors, 2 y roof vectors, and 3 minus z roof vectors. Now, instead of these unit vectors, let's draw corresponding component vectors. A of x, A of y, and A of z. In order to find vector A in this coordinate system, let's add its component vectors by using geometric construction. Shift vector A of y parallel to itself until its tail is at the head of vector A of x. Now shift vector A of z until its tail is at the head of vector A of y. Vector A is drawn from the center of coordinate system, or tail of vector A of x, to the head of vector A of z. Now let's introduce vector B in component form. Similarly, we have component vectors B of x, which is 2x roof vectors, B of y is 3 minus y roof vectors, and B of z is 3z roof vectors. Now, instead of these unit vectors, we draw a corresponding component vectors. B of x, B of y, and b of z. We find vector b in coordinate system by using geometric construction. Now let's add vector a and b by adding their components. We can see that by adding vectors a and b, we find vector c equal to minus x roof minus y roof vector. Now let's find vector c by using geometric construction, like this. As you can see, by using geometric construction, we get the same result, minus x roof minus y roof vector.